So we are to solve this equation. Y double prime plus y prime equals x plus 2.
Well, for page 121,
we initially get
we are to find the displacement y as function of time.
General equation for getting the values of y,
given these values,
y prime and y double prime. So
again, this displacement
y is equal to e raised to mx, y prime is equal to m,
so
m's e raised to mx. Y double prime is equal to m squared e raised to mx. Substituting the values of y prime and y double prime to the equation, so we get this
m times
equation, m squared
second derivative
m's e raised to mx plus m's e raised to mx is equal to 0. We assume that
quantity s plus y.
This is a homogeneous equation
From
for
there,
us to get
forming this
for us to solve this
algebra
yc.
here. So
Now,
will be easy.
in solving the roots, this characteristic equation,
w is equal to
equation, m times m plus y is equal to 0. Now get the roots of m is equal to 0 and m is equal to 1.
Here,
Now, this is a case
m with w over g.
Case 1.
W over g here,
Since our roots is not equal, so our yc will be c1 plus c2 raised to
negative t squared.
c2 times e raised to negative x
Equal to 0.
since this is negative.
To solve this, we get
Next,
that is
we now then solve
conjugate
the value of u1 and u2.
in this
To start with, this is our
get
equation.
the root of imaginary root.
For solving for yp,
We have a conjugate.
this will be our guide. Yp is equal to u1 y1 plus u2 y2.
Now we get
y1 is equal to 1
or y.
since in our yc, the pair of c1
0 and
is
beta
y1
equal to omega.
This is
So
1
since, e raised to alpha t times c1
and
cosine
y2
beta t plus c2
e
sine
raised to negative x. So y1 is equal to 1, y2 is equal to e raised to negative x.
e raised to
y1 is equal y1 prime is equal to 0, y2 prime is equal to negative x raised to negative x, and negative e raised to negative x.
c2 sine beta t.
This will be our guide getting closer to our goal u1 and u2.
Beta
u1 prime is
w
equal
to
to
beta.
w1
We have our w value here.
divided by w, and for u2 prime,
this
w2 over w. So
w
using the Wronskian matrix, this is our y1
times t plus c2 sine
y1 prime,
g over w
y2 and y2 prime.
t.
So
From
we will simply just work on the matrix,
we have
or our Wronskian matrix. So this will be the result, negative e raised to negative x. This is our w. For w1, this is 0 since
kind of square root of 60 pound change.
and then this will be our follow-up function,
6 pound times t.
which
So
is
from there,
x plus 2.
get the
Now,
solution.
this is
Y
our
is equal to c1
u2
cosine 8t plus sine 2
and u2 prime.
c2 sine 8t. So since we have
Performing the Wronskian matrix, we have a result of
use y
negative e raised to negative x times x plus 2. For W2, the matrix will be y1 is equal to y1 prime, 0, and function. So we have the result x plus 2 for W2.
0 to values of t.
Moving on,
C1
we can now then solve for U1 since we have the value of
C2 sine A
W1
N0 and V equal to 0.
W.
The remaining
So performing the
term
integral,
will be
U1 is equal to
10.
x squared plus 2, x squared over 2
definition
plus
y
2x.
Next will be
And for our U2,
the value for V.
we have U2 prime,
V now. The definition y prime
our
is equal to V.
W2
Derive
over our
the
W.
derivative of y. First derivative of y, we get
This is W1
equal to
over our
C1 sine 8t plus 8c2 cosine 8t. Now with the initial value of 0,
So forming the integral for U2, we get the value of U2, which is equal to negative x times e raised to x plus e raised to x minus 2
C1 sine
2 times e raised to x.
8c2 cosine 8.
Moving on, we can now then solve for yp, since yp is equal to u1 y1 plus u2 y2. Yp is equal to our u1 is x squared over 2 plus 2x. And our y1 is 1, so we have our u2 x squared over 2 plus 2x plus 1. For u2 y2, our u2 is negative x e raised to x plus e raised to x minus 2 e raised to x. Then our u2 is e raised to negative x. So then we have our yp is equal to x squared plus x squared over 2 plus x minus 1. So since this is the equation for solving y, we have yc previously is equal to c1 plus c2 times e raised to negative x, and our yp is equal to x squared over 2 plus x minus 1. So we have our equation y as our final solution. Y is equal to c1 plus c2 times e raised to negative x plus x squared over 2 plus x minus 1.